All right, thank you so much for joining us today. So in this video, we are going to go through quiz 2, 2023-2024. We have 20 questions. So I'll solve some, I'll give you some to also try it and leave your final results in the comment section. So it's always good for you to, know some shortcuts before, you take some quizzes, right? So let's look at this one. So we have f of x, and then we want to find f prime of x, right? So this is what we just need to do. So for us to do this, let's use the shortcut to do this. So this is cos s plus b sine x plus k divided by sine x. And then one thing that I'm going to say is always, when you're going to take the exams, to always check the function. They can even change this one to minus, and then you think it's the same question that you've solved here and you take the wrong answer, right? So it's good to know how to solve it. When you go and it's past question, since you know how to solve it, just go through the steps and confirm if the final result is indeed what we just did or is different, right? So what we are going to do here is, let's try and break this one down. So we know that a plus b divided by c is the same as a over c plus b over c. So I can write this one as a cos s divided by sine x plus b sine x divided by sine x plus 1 over k over sine x. So this is what I can do. And then I know that cos divided by sine is going to give us the cotangent, which is cot x, plus, now sine will cancel sine, so this one will be left with b. And then here, when I bring k out, it will be left with 1 divided by sine, and we know that 1 divided by sine is the cosecant of what? X. So now this is the simplification. Now we can differentiate. So we know that when I differentiate cotangent, I'm going to get minus cosecant what? Squared. So that is basically what I need. So minus a cosecant squared x. So from the option, I can see that the only one with cosecant squared is this. So this one, if this is the option, I don't need to even continue doing the differentiation. I just pick A as my results, unless maybe the final result is not there. So that's basically one way of doing that. And when I differentiate B, I'll get 0. And then we know that when you differentiate cosecant, what do you get? You get cosecant and then cot by minus. So when I differentiate this B, I'm going to get 0. So now when I differentiate cosecant, I'm going to get minus cosecant x and then cot x. So this is what I'm going to get. So let's try and see if this is part of the solution there. Good. So the one that I said you need to choose was right. So this is basically the same thing as this. So that is how, anytime you are solving objective question, look at the options too whilst you are solving, because some of the options are not tricky. As soon as you do something, you see that that's the only right option there, and then you just choose it. And then if you want to really want to confirm, and then you can finish everything and then you choose your option from there. So this is question 1, and then the answer here is supposed to be A. Let's look at question 2. So question 2, we want to use this information to answer question 2 to 3, right? Or question 2 and 3. So here we want to find the slope at s is equal to 1. So let's do that. Given y is equal to 9x squared plus 7x to the power 4, dy over dx is equal to 18x plus, when I differentiate this, I'm going to have 7 times, this is supposed to be 28x cubed. 7 times 4 should be 28, right? So we are using the power rule here. 2 will multiply the 9, subtract 1, and it gets 18. 4 will multiply the 7, giving us 28, and then subtract 1 and get minus 3. So this is my slope, and I need to evaluate this one at x is equal to 1. So plug in 1, and you get this. So this is 18 plus 28, and this is going to give out 46. So yes, indeed, we have the 46 here. So we are going to use the same question here to solve the question 3. So the question 3 is asking us to find the equation of the tangent at this point. So the first thing that we need here is the equation of the tangent, which is this, which is equal to dy over dx, x minus x1. So this here is my x1, y1. So this is x1, this is y1. So let's do that. y minus 2 is equal to dy over dx, and then x minus 1. But what is dy over dx? Remember, we are using this one to solve question 2 and 3, and we've already found dy over dx, which is 46. So we can just plug it in. 46 x minus 1. When I move the 2, minus 2 become positive 2. So let's simplify this and see what we are going to get. So I think they didn't even move it. They left it this side. Oops. This is asking us the equation of the normal line. Good. So I think I just did a mistake here. So equation of the normal to the curve should be minus 1 divided by dy over dx rather. Good. So minus dy over dx. So this is going to give us y minus 2 minus 1 divided by 46. So always read the question 2 as well. So this one is not tangent, and this is the normal line. Know that normal to the curve should be minus 1 divided by the slope. So I'll multiply through by 46. So I'm going to have 46 times y minus 2, which is equal to minus x minus 1. So 46y minus 2 times 46 is going to give us 92, which is equal to minus x plus 1. So let me look at how they grouped it. Okay. So I move the x to the left, 46y plus x is equal to, I move the 92 to the other side, 1 plus 92, and I'm going to have 46y plus 6 plus x is equal to 93. So let's move this guy up there and see if we have the solution there. So 46 plus and then 93. Okay, so we have it there, which is this one. No, not that one. Okay, so I think this one was supposed to be, this one's supposed to be equal to, good. So this one will be the answer right here. Good. And even if it is not equal to, this one is supposed to be equal to 0. So when I move 40, this plus x minus 93 is equal to 0. So the answer is still in A here. So that's how we are going to go through question 3. Let's look at question 4. Find the interval over which the function is increasing. So I'm still in the derivative videos are playing, so you know how to find the derivative. So here we need to use the product rule, right? So let's do that. F prime of x is equal to f of x is equal to x to the power 1 over 3, 8 minus x. So we need the critical values before. So this is what we can do. Product rule, a is equal to x to the power 1 over 3, b is equal to 8 minus x. So a prime, differentiate this using the power rule, be 1 over 3 x to the power minus 2 over 3, because when I subtract minus 1 from this, I get that. And when I differentiate b, I'm going to have minus 1. So product rule, multiply this to this and multiply this one to this. So f prime will be equal to minus x to the power 1 over 3 plus 1 over 3 x to the power minus 2 over 3 and then 8 minus x. So for us to set this one to 0 to find the critical values, we need to simplify this. So let's do that. 1 over 3 plus x, 8 minus x divided by 3 this. So let's find the LCM or use a shortcut. So this is divided by 1. So this times this plus this times this divided by this times that. So this is kind of divided by 1. So let me use my trick. So I multiply this by this. So having minus, we are going to have 3x squared divided by 3 times minus x 1 over 3 plus, then I multiply this one by this. So 1 times 8 minus x divided by 1 times this. So this trick works for all the functions. So squared 3. So this one, when I multiply, I'm going to have minus 3x. Then I need to add the exponent because they have the same base, x. So I'm going to have 2 over 3 plus 1 over 3 plus 8 minus x divided by 3x squared divided by 3. Now add this and get 1. So it means at the top is going to be minus 3x plus 8 minus x divided by 3x squared divided by 3. And guess what you are going to get here? 8 minus 4x divided by 3x squared 3. So now this is f prime, and we can now find the critical value. So as I said, with rational functions, if you want to find the critical values, pick the top, set it to 0, pick the down, set it to 0. So when we pick the top, we are going to have 8 minus 4x is equal to 0, 4x is equal to 8, and x should be equal to 2. Then when we pick the down and set it to 0, 3x is equal to 0. So x is equal to 0 and x should be 0. So the critical values should be 0 and 2. So these are the critical values, 0 and 2. Now I want to look at the interval over which the function is what? Increasing. So what we are going to do is now let's put this on the normal line and see where the function is increasing, right? So we have 0 and 2. So remember, with increasing and decreasing, we need to use the f prime function. So I'm going to pick any value here. Let me say minus 1, and let me say 1 here, and let me say 3 here. Then I'll plug them inside the f prime of x, right? So this one, we put it inside the f prime of x, because this is kind of like we are trying to find the local maximum. So plug in minus 1 inside this, right? Now note that this is kind of 8 minus 4x divided by, the denominator here can be written as 3x squared to the power 1 over 3. So we are not interested in the denominator, because since this one is squared, whether it's positive or negative, the denominator is going to be positive. So we are interested in the top, whether it's going to be positive or negative. You can use calculator to just check it. If we are using calculator, you just plug in minus 1 and find out whether you are getting a negative answer or positive answer. But since I'm not using calculator, plug in minus 1 and the top will be positive. So this one will be greater than 0, which is positive and meaning that it's going to increase. Plug in 1 and also going to be positive, meaning that this one too is increasing. Plug in 3, this will be 12, and then this one will be 12. 8 minus 12 is minus, so this is going to be decreasing because this is less than 0 and it's minus. So we can see that the increasing interval, what the question is asking us, is increasing interval. So we see that this is the increasing interval. So we can see that we need to move from negative infinity up to 0. So moving from negative infinity up to 0, and from 0 toward 2. That is where the function is increasing. So from this up to this, that's where the function is increasing. So let's check whether you have the answer there. Yes, we have it there, which is C. We have it right here. Good. So that is the increasing interval. Let's look at the next question. We want to look at the decreasing interval. So as soon as we are done with this, it's kind of like helping us to find out. So decreasing interval is this one, from 2 to positive infinity. So we are going to have from 2 to positive infinity. And this one is going to give us D here. Good. So this one helps us to find question 4 and 5. Good. Let's look at question 6. Compute the critical values of f of x. Oh, I think this one's supposed to be question 5 and 6. So this one is part of the questions. So the critical values are 0 and 2. So one question, we've done a lot in this. So 0 and 2, they are the critical values. Right. So one question, we're able to get 3 answers right from there. Now let's look at this one. We want to compute this using the implicit differentiation, right? So implicit differentiation is basically, now we are differentiating the function with respect to x, but the function is not explicit like the one that we did here. We saw that the function was explicit here, y was standing alone and it was equal to a function which is in terms of x. But this one is implicit because we cannot make y the subject alone, right? So let's use the idea of implicit differentiation to do that. So first we need to use the product rule here. So I'll maintain y and differentiate x squared. I'm going to get 2x plus. Now I maintain x squared and differentiate y and get dy over dx plus. When I differentiate 6y, I'm going to have 6 dy over dx plus. When I differentiate x, I'm going to get 1, which is equal to 0. So I'm going to have 2xy plus x squared dy over dx plus 6 dy over dx is equal to minus 1. When I move plus 1 to the left, to the right, I get a negative. Now I'll move this one to the right again, but I need to factor this and this out. So I'm going to have x squared plus 6 dy over dx is equal to minus 1 minus 2xy. So what will be dy over dx? This will be equal to minus 1 minus 2xy divided by x squared plus 6. So let's go and compare the final answer to the questions and see if we need to do multiplications or we are done. So looking at this, I think the answer is supposed to be this, minus 1, good. So I think we have the results there. We don't need to do much simplification. So that's what we are going to get for question 7. Now, if f of c is a local maximum of f, if f prime is greater than or equal to 0 for x lying between a and c, and this one will be less than 0 if this one is also learning this one. This one is true. So I think I have video that is coming on local maximum and minimum, and you are going to understand these things that we are doing very well, like critical values and those. But because of your quiz, that's the reason why I needed to do this before, we finish watching all the videos. Let's look at question 9. I love question 9. We want to differentiate this, so don't get scared with the function. If you know how to differentiate individual function, as I said, the general rule and then the rule for differentiating individual function, if you know how to do all those things, then you are good to go. So what can I do here? First, I know that here I need to pick the general rule, product rule, and then the sum rule. So that's the first thing that I need to know. So my y prime will be equal to, now I know the product rule, but do I know how to differentiate individual function? So let me let a to be equal to this. What is a prime? When I differentiate e to the power x, I get e to the power x, as we all know. And then when I differentiate b, okay, let me let b to be equal to sine ln of 2x. Then what will be b prime? Let's figure it out. So b prime, here we need to use a change rule. So change rule, first the derivative will hit the sign. So I'm going to have cos ln of 2x times, then I need to differentiate what is inside the bracket or the parenthesis. So I'm going to have ln of 2x. So this is going to give us cos ln 2x times, when I differentiate ln 2x, what am I going to get? So ln of 2x is something like this. So we said for us to differentiate a ln function, 1 divided by what is inside the parenthesis times when we differentiate what is inside the parenthesis, which is 2x, and it's going to give us 2. So we are going to have 2 cancelling 2. So this will be cos ln of 2x divided by x. So this is the product rule for this only. So now let's write out the y prime. So y prime will be equal to this times this, which is going to give us es cos ln of 2x divided by x plus this times that. So we are going to have ex sine ln of 2x. Now what we've done here is for only this. Now we need to also differentiate an exponential function. We know how to differentiate an exponential function, right? We differentiate what is on the top and we use to multiply the whole function. So we differentiate what is on the top cos s times the whole function. So this is how we differentiate an exponential function. So y prime will be equal to ex cos ln of 2x divided by x plus ex sine ln of 2x plus, when I differentiate cos s, I get minus, so minus sine x e to the power cos x. So this is what you are going to get. Let's move it up there and go and see if we have our solution there with us. So let me just leave it here and just move this guy a little bit. Good. So let's check which one is giving us the right resource, right? So first of all, let's look at them by term by term. So we can see that minus sign, this is here. So no doubt, okay, it's also here. So no doubt that option A and B is out, right? Because this is plus and we have this one here. So we are looking at option this and this. Now we can also see that we have this option here. So the way they arrange the solution. So this is also here. So of course the answer is supposed to be C. And then we have this one also here. E to the power x divided by x, e to the power x divided by x times this, which is also here. So this one should be giving us this right here. So that's question 9. Let's look at question 10. We need to take derivative of this one too. F of x is equal to x squared plus 1. I'll give you some to do very soon. Plus 8 squared plus 1. So you need to remember the rules. Now this one I'm going to use change rule. And this one I'm going to use the constant base rule, right? So change rule for this says that if I want to differentiate this, I need to cater for the power first. So 8 drop down. I don't touch what is inside the parenthesis. And then I subtract 1 from the top. So when I'm done, then I'll multiply it by the derivative of what is inside the parenthesis, this. So I'm going to have x squared plus 1 plus, so this is how to differentiate this change rule. So this is the change rule that we've used here. 8 drops down, maintain everything in the parenthesis, subtract 1, getting 7, then now differentiate what is inside the parenthesis. Then plus, this is the constant base rule. So the constant base rule says that differentiate what is on the top, which is x squared plus 1, right? Then multiply it by the whole function. It's like differentiating an exponential rule. So now multiply it by the whole function times ln of the base. So we have the base and we have the power here. So differentiate the power, which is here, multiply it by the whole function times ln of the base, which is this. Now let's simplify and see if we get it there. So 8x squared plus 1 times, when I differentiate this, I get 2x, right? Then plus, this is also 2x e 8 to the power x squared plus 1 times ln of 8. So let's see if we have something like this inside the solution. Let's check it out. So I have this, I have ln 8 and I have this one. So this is true. This is also true, right? Good. So this is true and this is also true. But this has no 2x and this also has no 2x. So it means that there was typo inside the solution because we are having this, which is here and also here. But this one, okay, this one too is also even out, right? Because this one's supposed to be 7. So this one is the one with a 7, but lack 2x. So let me add 2x to this one, and then so this one lacks 2x. So we add 2x to it, and then we have our final answer here to be D. Good. So that is question 10. Now differentiate this and leave your final results in the comment section. Okay, I want to see who is going to get it right. Okay, so differentiate this and leave your final results in the comment section. Okay, find the approximate change when x increases from 6 to that, given this. Okay, so this is just, I think it's a formula that we just need to know, right? So we want to look at the change. So first we need dy over dx, which is 4x minus 3. Is that right? Now, when you look at the change, 6 to 6.02, the change in x here is equal to 0.2, right? Because the change in x here is 0.6.02 minus 6, which is going to give us this 0.02. So this is the change in x, right? So now, since we want to look at the small change, then what we need to do here is, now this is going to be, we need to put x inside, x equal to 6 inside. So this was going to be 4 times 6 minus 3, and this is 24 minus 3, and this is going to give us 21. Is that right? 6 times 4 is 24 minus 3 is going to give us 21. Is that right? Yes, of course. So we are going to just multiply this to this, and then we are done, right? So the approximate change is equal to dy over dx times the change in x. So that's basically what we are going to do. So this is going to be 21 times 0.02, and I'm not using calculator, so I think this is the same as 21 times 2 divided by 100, and this 21 times 2 is 42 divided by 100, and this is going to give us 0.42. Okay, we have it here. Good. So this will be the change. So what did I do? I need dy over dx times the change in x. So dy over dx is equal to this, but here we plug in the exact value inside for x, right? Because then for us to look at the change in x, this minus this, and then we get it to be this, and then we just multiply them, and then we get what is here. Let's look at question 13 and 14, right? Determine the time at which the production was maximum. So since we are talking about maximum, and we are trying to talk about, let's say, local maximum, right? So we need critical values. That's basically what we need. So let's do that. P of t is equal to 80t divided by t squared plus 4. So I'm going to use a quotient rule, right? So u is equal to 80t, u prime will be equal to 80. Then is equal to t squared plus 4, and then prime will be 2t. So don't forget the product rule. So p prime of t is going to give us u prime, then u prime minus then prime u divided by then squared. Plug them in, and we are going to have t squared plus 4 times u prime is 80 minus then prime is 2t times 80t divided by t squared plus 4 all squared. So this is the quotient rule. Now let's try and simplify what we have there. So we are going to have 80t squared plus 80 times 4 is, I think, 8 times 4 is 32. So this one will be 320 minus 160 t divided by t squared divided by t squared plus 4 all squared. So let's see, we are going to have 320 minus 80t squared divided by t squared plus 4 all squared. So as I said, for rational functions, for us to find the critical values, set the denominator to 0 and set the top two to 0. So let's set the top to 0. This minus 80 squared is equal to 0. 80 squared is equal to 320. So t squared will be equal to 4, and then t will be equal to plus or minus 2. But the idea is that the denominator, because this one is squared and this one is positive, there's no value that will make this one 0. So this will be the critical values, plus or minus 2. So the time that will make sure that this is at its maximum is, oh, okay. So they've given us interval. We need to pay attention to this. So we need to pick the critical value that is in between this. So this one's supposed to be t. In between this. So looking at this, minus 2 and 2, the one which is between this is 2. So the answer rather supposed to be C. So here, if you don't pay attention, you get it wrong, even though you were able to find the critical values right. So this is supposed to be 2. And then what was the maximum production level? So maximum production level was, now we are getting this one to be 2. So plug it inside this and then you are done. So P of 2 will be equal to 80 times 2 divided by 2 squared plus 4. This is 160 divided by 8. And 8 goes to 16, 2, so 20. Right, good. So we are going to have this one. So this is giving us A. Now let's look at question 15. Question 15, I forgot to write the function. So the function is supposed to be f of x is equal to 5 plus 8x squared plus 4x to the power 3 minus x to the power 4. So this is the function that we're supposed to do. You'll be using. So since we want to find the absolute minimum point, then we need the critical values. So for critical values, we need to find f prime. And then when I differentiate a constant to be 0, so this is going to give us 16x plus 12x squared minus 4x cubed. So that's what we are going to get. And I think we can factor 4x out, and it will be left with 4 plus 3x minus x squared. Yeah, I think so. This is what we can do here. And then for critical values, f prime should be 0. So 4x plus 3x minus x squared is equal to 0. So for x is equal to 0, and one of the critical values, x, should be equal to 0. Then we pick 4 plus 3x minus x squared to be equal to 0. So what I can do is I can move all of them to the right side so that I can write it as x squared minus 3x minus 4x is equal to 0. So let's find the values factors for this. I think I can use minus 1 and minus 4. So I can use something like plus x minus 4x minus that. I think that's right. So the one with the blue and the one with the red. So with the blue, when I factor x out, I have x plus 1. And the one with the red, when I factor minus 4x, I have x plus 1. So I'm going to have x plus 1, x minus 4. This one, you can use calculator to figure out the point. And then x should be equal to minus 1 and s should be equal to 4 when you solve this one. Good. So the critical values here are 0, minus 1, and 4. So what we are going to do is, now for us to find the absolute minimum and maximum, we need to put this point on the table to figure out which one is going to give us the minimum, which one is going to give us the maximum. So let's do that. I have my table here. These are my x value. We had x to be 0. We had x to be minus 1 and 4. So let me plug in f of 0, f of minus 1, and f of 4 inside the function and see what we are going to get. So what is f of 0? Whenever I plug in 0, everything goes to 0. So I'm going to have f of 0 to be 5. Plug in minus 1. Minus 1, this one will be squared. So I'm going to have 5 plus 8 minus 4 minus 1. So this is going to be 5. And this is going to be 5. So I'm going to get 8 from there. Then when I plug in 4, let me use my calculator and see what I'm going to get when I plug in 4. So 4 here, this is going to be 5 plus 4 squared is 16. 16 times 8 is going to give us 128 plus 4 to the power 3 is 64. 64 times 4 is going to give us 256 minus 4 to the power 4 is going to give us 256. So this one will cancel this, and when I add this one, I'm going to have 138. 3. So which one is the minimum? The minimum is this one. So it means that the coordinate or the minimum point will be the x coordinate, which is 0, and then the y coordinate, which is 5. So we are going to have B from this. Good. And let's look at 16. We are almost there, left with 4 questions. Now let's look at question 16. Okay. So this one's supposed to be equal to. So we have r of x, which is equal to this, and we want to find the point of inflection. So for point of inflection, the second derivative must be equal to 0. So if that's the case, then we need f r prime prime. So since r is x to the power 4 minus 4x to the power 3, r prime is going to give us 4x to the power 3, 12x squared. Let's look for r prime prime of x, and this is going to be 12x squared minus 24x. So for point of inflection, r prime prime of x should be equal to 0. So you are going to have something like this. Let me say 12 x squared minus 12 minus 24 x to be equal to 0. Here I can factor 12x out, and to be left with x minus 2 is equal to 0. So for the point of inflection, 12x is equal to 0 and x is equal to 0. X minus 2 is equal to 0 and x is equal to 2. So 0 and 2 might be the point of inflection, right? So that's basically what we need. So 0 and 2. Now, since we are talking about point and we've gotten the s coordinate, we need the y coordinate. So what we are going to do is we are going to assume when s is equal to 0, what are we going to get? When I plug in the 0 here, this one too will be 0. So y will be 0. Then when x is equal to 2, plug in 2 here. 2 to the power 4 is going to give us, I think, 16. And then 2 to the power, this is going to give us 8. 8 times, let me say 8 times 4 is going to give us, I think, 32. And when I add this one, I'm going to have 48. I think so. Is it going to give me 48? Yeah, something like that. So I'm going to get 48. But let me check through my solution again and see something. This is going to give me this. This is going to give me 12x squared. And this is 24. And this is 12. So when I factor, this is 12. Is that right? And this is 24. When I factor this one, 12 times this is going to get given as 20. So 0 and 2. So 0 and 2 is supposed to be right. Okay. So right now we have this, which is here, and we have this, which is also here. But I'm just still looking at this. Is it that? Oh, okay. So I think there is a big mistake here. This is supposed to be plus, 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 and this will be plus, and this will be minus 2. Good. So if that one is minus 2, then this one is supposed to be minus 2. So when I plug it inside, this one will be minus, and this is going to give us minus 16. Okay. So minus 16. So the point is 0, 0, and minus 2, and minus 16. So which is going to give us A. One small mistake, and we are dead already. Now let's differentiate this. We want to differentiate the length function 3x squared plus 2x minus 1. So we said for a length function, 1 divided by what is inside the parentheses, which is 3x squared plus 2x minus 1, times, then we differentiate what is inside the parentheses. So let's do that. When I differentiate this, what am I going to get? I'm going to have 6. So this is going to give us 6x plus 2. So I'm going to have 6x plus 2 divided by 3x squared plus 2x minus 1. So very simple from there. And we are going to have B. Okay. 3 more questions. Should I leave this one for you to do it? Yes, I think so. Let me just leave this one for you to do it. So use the implicit differentiation to do this. You have x and then you just plug it in and then you just find for dy over the x. So okay, you let me do it. Let me do it. So this is going to be 2x plus 2y dy over the x, which is equal to 0. So implicit differentiation, differentiate this and get 2x, differentiate this and get 2y, but when you differentiate y, you get something like this. So it's like you are using the chain rule, y squared. So differentiate this, 2y, and differentiate what is inside this, and you are getting this. Then we know that s is equal to 4, right? So when you plug in 4, you are going to have something like this. Let me say something like 2 times 4, which is equal to 2y plus 2y dy over the x is equal to 0. So 8 plus 2y dy over the x is equal to 0. So what am I going to get from here? 2y dy over the x is equal to minus 8. Divide through by 2y, and dy over the x is going to be minus 8 divided by 2y. And this should be minus 4 divided by y. Our solution has no results with y, so we need to figure out something. So this is what I'm going to show you here. We need to use this one to find for y, right? So x squared plus y squared is equal to 24. We know that x is equal to 4, so this is what we can do. We can pick 4 squared plus y squared is equal to 24. So we are going to have 16 plus y squared is equal to 24. And then y squared will be equal to 24 minus 16. Y squared will be equal to 24 minus 16 is going to give us what? Okay, so I think there is a big mistake here. This one's supposed to be 25 from the question. This one's supposed to be 25. Yeah. This one is right because when you differentiate 25, you get 0. So this one should be 25. So 25 minus 16 is going to give us 9. Then when I pick square root of 9, I'm going to get plus or minus 3, right? So now plug in it here and we are going to have dy over dx to be equal to minus 4 divided by plus or minus 3, right? So when the plus goes with the minus, it becomes minus, and when minus goes with plus, it goes with minus, it becomes minus. So this is basically plus or minus 4 over 3, right? Because minus 4 divided by 3 is minus 4 over 3, and then minus 4 divided by minus 3 will be 4 divided by 3. So we are going to have plus 4 over 3 minus 4 over 3, which is plus or minus 4 over 3, and this is going to give us a. Good. So that is 18. Okay, I think it's good that I solved this one. Now let's do 19. We do 20, then we are done. So here y is equal to the length function of sine 3x. So we know how to differentiate a length function. 1 divided by what is inside the parentheses, or times the derivative of what is inside the parentheses, which is sine 3x. So this is going to give us 1 divided by sine 3x times, when I differentiate sine, what am I going to get? I'm going to have cos 3x times, I need to differentiate what is inside again, which is change rule. So this is going to give me 3. So this is going to give us 3 cos 3x divided by sine 3x. What is cos over sine? Because we don't have that result here. So we know that cos over sine is the cotangent. So this is going to be 3 cotangent of 3x. So that's what we just need to know. So this is B. Last question, then we are done. Determine the area of the largest piece of a rectangle ground that can be enclosed by 100 meters of fencing if the part of an existing straight line wall is used as one side. So we are assuming that one side of the fence is, alongside with a straight line, right? So what we are going to do is we are going to assume that we have this one to be x, this one will be x, and this one will be y. So we know that the constraint here is 100. We need to use 100 as, so it said determine the area of the largest species that can be enclosed by this fencing. So for us to fence this wall, we need 100 meters or 100 materials. So it means that 2x plus y should be equal to 100. So when I add this plus this plus this should be equal to the cost, right? Then we know that area of a rectangle is x times y. So here we can make y the subject and plug it inside this. So when I do that, I'm going to have the area to be equal to x times 100 minus 2x. And guess what? This is going to give me 100x minus 2x squared. Now, what I need to do here is, now since we want to find the largest area, so it's like we want to find the maximum, then we need to find the critical values by differentiating the function and finding the critical values. So when I differentiate 100x, I get 100, minus when I differentiate 2x squared, I get 4x. So 100 minus 4x should be equal to 0. 4x is equal to 100. And guess what? X should be equal to 25. So now that I've gotten x to be 25, I can find for y. So y is equal to 100 minus 2 times 25, which is going to be 100 minus 50. And this is 50. So now that we want to find the area, what is x times y, then we are going to have 25 times 50. So what is 25 times 50? 25 times 50 is 1250. So we are going to have D. Wow. Wow. So I wish you all the best in your quiz and see you in the next video.